Good morning to all. How are you? Welcome to the another lecture in the unit 1 of your paper spectroscopy. The Woodward Fieser rule. It's the lecture number 5. The outline of this lecture will proceed to the following points. The review of the previous lecture, objective, learning outcome, the introduction of the Woodward Fieser rules. Then there are the set of rules. The WoodWard-Fieser rules for conjugated dienes we will discuss in this lecture with the various examples, exercises there, references and SELO. In the previous lecture, we have discussed about the various absorption bands found in the UV visible spectra, and we have seen the UV visible spectrophotometer. The instrumentation part with all the basic features, how they are attached to the main components, we have discussed in the previous lecture. The objective of the lecture is to learn how to calculate the lambda max or the wavelength maximum of the organic compounds and understand the molecular structure. It also familiarize the Woodward-Fieser rule among all. The learning outcome, the students will be able to understand about the set of rules which are designed to calculate the lambda max of specifically the conjugated dienes. So the learning outcome of this lecture is to understand that rules and learn how to calculate the lambda max of the conjugated dienes. So let's start. In 1945, the Robert Burns WoodWard gave us certain rules to correlate the lambda max and the molecular structure of the compound. And in 1959, the Louis Frederick Fieser modified these rules with more experimental data. And that modified rule is known as the Woodward-Fieser rule. It's the combined rule. In 1945, the rules were made by Woodward and then it was modified by the Fieser in 59. So the modified rule is known as Woodward-Fieser rule. And these rules are used to predict the wavelength of the absorption maximum, that is lambda max, in the ultraviolet visible spectrum of a given compound. So, which type of the radiation the compound is absorbing and which would be its lambda max or the wavelength of the maximum absorbance, that can be find out, that can be predict out with the help of these rules known as Woodward-Fieser rule. Each type of the diene or triene system, you all know diene means the compound which is possessing the two double bonds, or triene, that is the three double bonds, is having a certain fixed value of the absorbance, or we can say a particular fixed lambda max, and that constitute the base value or the parent value. So to understand the Woodward-Fieser rule, the first thing is to know about the base value or the parent value of that compound. So if we are talking about the dienes, they are having the fixed base value. If we talk about the trienes, they also having the fixed value, that is called a base value or the parent value. So that we should know when we are determining the lambda max by the Woodward-Fieser rule. The contribution made by the alkyl substituents or the ring residue. So the base value and the parent value is fixed. Now, to that compound, if any of the alkyl group is present or a ring residue is present, an extra ring is there, or the double bond extending the conjugation, or the polar groups like chloro, bromo, which are added to that compound or that basic value. So each one of the alkyl constituent or a ring or a bond, double bond or the polar groups, these values should be added in the basic value to obtain the lambda max for that particular compound. So according to the Woodward's rule, the lambda max is equal to base value, that is the parent value, plus the sum of the substituent contribution. This is the sign of sum of. So how many substituents are attached to that basic compound? That substituent contributions are added in that base value, and other contributions like the double bond, like the polar groups, if the groups are attached to that compound, so that should also be added in the base value. So we can determine the lambda max according to this formula. We go for using the base value and then according to the substituents attached in it or the other groups attached to it, their contribution should be added in the base value. So in Woodward-Fieser rule, there are three set of rules. The one is the Woodward-Fieser rule for conjugated dienes and polyenes. The conjugated dienes are the compounds which is having the double bond in the conjugation with the single bond. Okay, the alternate single to the double, and that is called the conjugation. Okay, understood? Yes. The second one is the unsaturated carbonyl compounds, and the third one is for aromatic compounds or benzoyl derivatives. So the three set of rules are there in the Woodward-Fieser rule. It is given for the conjugated dienes and polyenes, then for the unsaturated carbonyl compounds and the aromatic compounds or the benzoyl derivatives. So let's start the Woodward-Fieser rules for the conjugated dienes and polyenes. So conjugated dienes and polyenes, how we can calculate the lambda max in these compounds. So there are two types of conjugated dienes if we talk about, that is acyclic and cyclic. The acyclic dienes are the open chain compounds having the conjugation of the alternate single to the double bond like butadiene, It is acyclic diene. Okay. And if we talk about the cyclic dienes, they are having the two double bonds in the cyclic form or ring form. So the cyclic dienes are of two types. The one is homoannular diene and the another one is heteroannular diene. So if we want to calculate the lambda max in the cyclic dienes, we should first recognize whether the conjugated diene or cyclic diene is homoannular or heteroannular. In the homoannular diene, here you can see it's the cyclic diene having the conjugated double bond in the same ring. Same ring. If we are having the double bond in the conjugation in the same ring, that cyclic dienes are called homoannular dienes. Understood? So here you can see this is an example of homoannular diene. That's 3D picture it is. The carbon is attached to the hydrogen here. So you can see here the conjugation diene. Here is the double bond. Then we have a single bond. Then here is the double bond. Okay. Then we have a single bond here. And then we have a double bond again. Then single. Understood? Double, single, double, single. It become conjugation. So this is the homoannular diene because this conjugation is in the same ring. Understood? So if you find this kind of the cyclic diene, so this is having the fixed value of the lambda max. The homoannular diene has the base value or the parent value that is fixed. Understood? So we will take the value of homoannular diene for the calculation. Yes. The second is the heteroannular diene. Now you can see what is the heteroannular diene. These are the cyclic dienes having the conjugated double bonds in the different rings. Understood? So there are two rings here and we are having the conjugation in the different ring. Here you can see here is the double bond. Then we have a single. Then double and then single. So here the conjugation is going to the next ring. So that is called the heteroannular diene. Okay. So if the conjugation or the conjugated double bond is in the different ring, that are called heteroannular diene, and it is also having the base value or the fixed value or the parent value that should be taken in the calculation. Now we see what is endocyclic bond. To understand the WoodWard Fieser rule, so we should take the base value or the parent value of the compound, or if we are talking about dienes, so if we recognize the homoannular diene, we take the value of homoannular. Either the heteroannular is there, we take the value of heteroannular. Now other substituents or the groups are to be added in the base value. So let's see the another point, that is endocyclic bond. What is endocyclic bond? Endocyclic bond is the double bond present in the ring. Okay, inside the ring we can say that is the endocyclic bond. So in a conjugation, if we are having The endocyclic bond that can be understand, it is present in the ring. That bond is called endocyclic. So you have understood the endocyclic bond. Now exocyclic double bond. How you understand and how you can differentiate the endocyclic to the exocyclic double bonds. The double bond in which one of the doubly bonded atom is a part of a ring system. Okay. So here you can see an example. Here ring A has one exocyclic. Exocyclic means it is having one double bond. This bond is treated as endocyclic. But when it is going to attach to the another ring, so there is in the attachment, this is the bond which is the part of this ring A. Means the A ring is having both type of the bond, endocyclic as well as this one is exocyclic. Now if we see from the point of view, the B ring. The B ring is having endocyclic. Okay, this is because the inner double bond inside the ring, it is treated as the endocyclic. But the exocyclic bond is there or not? This is endocyclic for the B. But B is having exocyclic or not? B is not having the exocyclic because this is, you just see here, the attachment. Because from the side A, this is attached to the ring A. But from the side B, there is no attachment. It is far away. Okay. So this is not to be treated as exocyclic bond from B. So B is having only one endocyclic, not exocyclic bond. So this you can understood which bond to be treated as exocyclic. Because if the compound possesses the exocyclic bond, means we have to add the value to the base value. Now the next point is double bond extending. So how we understand whether the double bond is extending or not? When more double bonds are present other than the conjugation. That is called double bond extending. So take the conjugation part and then you see whether some extended double bonds are there or not. So if I take the conjugation here, this is the double, this is the single, then double, this is the conjugated part. Okay. From this part, you can see the more double bonds are there. Yes, it is there. More double bonds having in the conjugation. Beyond other than the conjugation, it is to be seen, this is the double bond. So that is to be treated as double bond extending. Now, what values to be added to the parent value? So here we can say for the acyclic conjugated dienes, means that is of open chain, and heteroannular conjugated dienes, always taken the base value or the parent value 215 nanometer. This we have to remember. These base value, parent value and the substituent value, how much we have to add it, that table we have to remember so that we can have the calculation of the lambda max. So for acyclic conjugated dienes and the heteroannular conjugated dienes, what is the parent value? 215 nanometer. And if we are having the homoannular conjugated dienes, what the value it should be taken? 253 nanometer. Understood? For acyclic and conjugated dienes and heteroadular, how much value to be taken up? 215 nanometer. Yes. And for homoannular conjugated dienes, how much we have to take? 253 nanometer. Now, for acyclic trines, if we are taking the triple bond, that is open chain, what's the parent value is? 245 nanometer. If we are having 3 double bonds, and that is in the open chain, not in the ring. So we take the base value for the calculation, 245 nanometers. Now we see in that base value, first we have to use the base value by recognizing the type of the conjugated dienes. Now we have the increments or the addition of the values to the base value. Each alkyl substitute or a ring, if besides your parent compound, if more ring is attached, more alkyl group is attached, each alkyl group, each ring should be added how much value? 5 nanometer for each. If we are having 2 alkyl group attached, 2 into 5. If we have 2 ring attached, 2 into 5. If we have 3 ring attached, 3 alkyl groups, 3 into 5. Understood? The next is the exocyclic double bond. Other than the conjugation, if we are having, but exocyclic, it should be the part of that ring. Okay, we have seen the difference between endocyclic and exocyclic. So, if we have the exocyclic double bond, 5 nanometer should be added in the base value. Yes. And other than the conjugation, if we are having double bond extending, means how much it is to be added? 30 nanometers. So this you should remember. What's the first rule? The first rule is the recognizing the type of the conjugated diene and its base value. If it is acyclic, if it is homoannular, heteroannular, okay, acyclic trines, then we have the increments. Alkyl or ring, each 5 nanometers. Exocyclic, that is 5 nanometers, and double bond extending conjugation, that is of 30 nanometer. Then we have the oxochromes. You understand what are the oxochromes? The oxochromes, if it is attaching to the compound, so there also the values are added in the base, like OR. Okay. OR, how much? If it is there in oxochrome, 6 nanometer is added. SR, 30 nanometer. Chloro, bromo, each, if it is adding 5 nanometers. Yes. We have amine group NR2, that is 60 nanometers, and CH3CaO. No addition is required for this oxochrome. So you have to remember all the values to be added in the base or the parent value. So let's see, we have an example. The WoodWard Fieser rule for conjugated dienes and polyenes, we are taking example number 1. So this is an conjugated diene. Whether it is cyclic or acyclic, tell me. Whether it is cyclic or acyclic, what would be the answer? Yes, acyclic. The ring is not there. This is the branched acyclic. Okay. So it is a conjugated diene? Yes. Here is the double, then single, then double, double, single, double. This is the conjugation part. Okay. This is the part where the conjugation is there. Now we see, if we are talking to this part, the addition to this part, and this part to be taken as the parent compound. Now, other addition to this compound, here this is the line of our parent compound. Now, beyond this line we have to see the other additions. So here is the addition. Here you can see this is the addition, this is the addition which is going to attach to this compound. 1 and 2 attachment is there. Understood? So what's the base value of the acyclic diene? This is the acyclic diene parent compound. How much base value should be taken up? That is 215 nanometer. Yes, 215 nanometer is the base value. So this is the 215 nanometer. This we have seen in the structure. This compound is taken as the parent and its value is 215 nanometer. Okay. Then we can see here the alkyl substitute or a ring residue at the carbon 3 and 5. The two addition is there for the alkyl groups, because here to satisfy the valency the two alkyl groups should be added. So each one of the alkyl group, how much? 5 nanometer. So if there are two, how much? 10 nanometers to be added. There are the two attachments from here side. So what would be its lambda max? It is 215 plus 10. It should the answer come 225 nanometer is the right answer. For this acyclic diene, the lambda max should be observed at 225 nanometers. So this is the value you get by the structure. And if we see with the instrument UV visible spectrometer, what would be the observed value? The observed value is here 225 plus minus 5 nanometer. So nearby, that is only the value. It can be the 5 upper and 5 below, so that can be taken into the consideration. So 225 nanometer is the lambda max of this conjugated diene. So likewise we can determine the lambda max. So here you can see the another example to calculate the lambda max. So whether this compound is cyclic diene or acyclic diene. Of course, the cyclic diene. So if we understand it is the cyclic diene, so whether it is homoannular or heteroannular. So if you see here two different rings and the conjugation is there from the carbon 1, here the double, single, double. So this is the parent compound which is exhibiting the conjugation, that is heteroannular diene. What would be the base value of heteroannular diene? The base value is 215 nanometers. Remember, for the acyclic and the heteroannular dienes, the parent value or the base value should be taken as 215 nanometer, and for homoannular 253 nanometers. So that is your the parent compound heteroannular. The base value should be taken up 250. So here you can see this is the parent heteroannular we have identified and the value to be taken as 250. Now if we see their attachments. Now if we go for the this conjugation part and see the attachments. So the alkyl substitute or a ring residue, we can have the carbon here 1. This is one part. This is the second part. This is the third part and this is the fourth part. So 4 attachments are there that to be added. Each one of it is added 20 nanometers. So 20 nanometers should be added. Then whether they are having exocyclic double bond. So you can see here with the ring whether the exocyclic bond is for B in respect of B ring. Yeah, in respect of the B ring. This is the endocyclic bond if we talk about B ring. So we have one exocyclic bond according to the B ring. So 15 nanometers for the exocyclic bond is added. So what would be the calculation? The 215, then 20, then plus 5, that is 240 nanometer is the answer. So the observed value is 240 plus minus 5. That is to be seen for this compound. Understood? So if you understand the WoodWard-Fieser rule for the conjugated dienes and the polyenes, the set of rules to be followed, so you can go for the exercise here and practice more and more compound for the calculation. What are the WoodWard-Fieser rules for the conjugated dienes? You have to remember all the rules for the parent compound, for which we have to go for the increments, for the alkyl substituents, exocyclic bonds, extended conjugation. So all rules you have to remember for the calculation. So this question help you in remembering all the rules. So write down the rules so that you cannot forget in the calculation, and then you practice the calculation in these dienes. So here the examples are given, this 1, 2 and 3. Go with the calculation of the lambda max of these conjugated dienes and have your answers. So these are the references which are to be taken for the calculation, the WoodWard-Fieser rules. So these are the SELO for the topic. The concept of the topic, application, the thinking skills, to just learn the logic behind the calculation so that your value, which is very correlated to the molecular structure. From the molecular structure, you can able to find out the lambda max. So this is all about for the conjugated dienes and polyenes. You have to practice more questions for the calculation. Okay. Thank you and have a great day.